Good morning, y'all. My name is Ellen Langford,
And I'm Nicole Vigilant.
and our UGROW project is over the symmetry and complexity of Swish with, of course, our mentor, Dr. Cobb.
Well, what is Swish? So, Swish is a card game where we use 60 transparent cards, and each card has one ball and one hoop placed on a 4x3 grid. So, this is an example of what a card looks like. And as you can see, we have one ball and one hoop. And balls and hoops are colored based on their position. So, we have four positions for blue, as you can see on our image on the right. We also have four positions for yellow, whereas for green and reds, we only have two positions each. And the goal of the game is to make a swish by stacking cards to match balls to hoops, where every hoop is matched to every ball. And cards can be rotated and flipped to make swishes using symmetry operations, which is why it's very important that these cards are transparent. That way we could do all of these cool symmetry operations that Ellen will tell you more about.
So, some important definitions for you guys to know. A swish is a set of cards where every position has the same number of hoops as balls. So, we have an example here for you, and we also have it on those big cards for you. And as you can see, if you line up those symbols correctly and stack them on top of each other, it makes a swish. Every hoop is lined up to every ball. A dunk is a position on a swish with the same number of balls as hoops, but not zero, of course. So, for example, the swish above has three dunks. A proto swish is a set of cards that can be rearranged and transformed to make a swish. So we have those same cards here, as Nicole is showing you, but she has rearranged and flipped and rotated them to where not all the symbols line up again. So same cards, they could make a swish, but right now they're just a proto swish. And one last definition, a deck view is a way of looking at a deck of cards, usually a completed swish, where all of the symbols can be seen. So talking about these symmetry operations, because these cards are transparent, there are a couple different ways that we can see symmetry within them. So if we start with the identity card with that yellow hoop and blue ball, we could do a vertical flip, which reflects it across the vertical axis. We could do a horizontal flip, which reflects it across the horizontal axis. And we can do a rotation, which rotates the card around the origin 180 degrees. Something is interesting about these is if you do a vertical flip and then a horizontal flip, you get the same card as the rotation, as Nicole just showed us. And these symmetry operations are integral to how these positions are colored on the card. So the reason that all of the blue positions are colored blue is because if you start with a symbol in that top left-hand corner, using those symmetry operations, you can actually get to all of the other blue positions. Same with yellow. If you start with a symbol in any one of those yellow positions, you can use those symmetry operations to get to all of that symbol to all of the other yellow positions. Same with green, same with red. But you're not going to be able to, for example, get a blue symbol to be in a yellow position just because of the way that those cards are set up and arranged and because of these specific symmetry operations.
So just a little bit more about how we play this game. So as you can see, we have a 4x4 grid of cards here. So that means we have 16 cards that we place down. And usually what happens is if a player sees there's a swish on the table, they would say swish and they would show it. And if it does make a swish, then they get to keep those cards. And as more players form more swishes, the dealer ensures that we always have 16 cards laid out until we end the game. So let's actually play. How many swishes can you find? Well, I don't know about you, but I found two different swishes. So firstly, we have a two-card swish with our blue and yellow cards. And if you look at the second card that we have circled in red, we had to use one of our symmetry operations to actually line them up to form that two-card swish. And we also have a three-card swish where we also use the same symmetry operations to line up the cards and stack them on top of each other to form that three-card swish.
So, what makes Swish so mathematically interesting? There are a couple different things. Firstly, the symmetry that we've been talking about. So, the fact that cards can be rotated and flipped without changing that underlying structure of the card is super interesting and lets us do a lot of different things with them. There's also combinatorics. So, how many different ways can cards combine into valid swishes? And spoilers, as you will see later, there is a lot. And then there's also scalability. So we can study decks of different sizes and look for patterns across all of them. The standard Swish deck has 60 cards, but by duplicating certain cards or all of the cards, you can create different size decks and we can find patterns across all of these size decks.
So something that we started with when we first started this research was actually counting the cards. So as you can see, we have three different size decks. We have our normal 60 card deck. We also have a 36 card deck as well as a 72 card deck. And how we categorize this was by the color of the different symbols of the balls versus the hoops, basically. So we also found out that there were 36 unique cards in a 60 card deck because we removed all of the duplicates from that 60 card deck and we were left with that 36 unique cards. And by duplicating that 36 card deck, we came up with that 72 card deck. And we just looked at the different patterns and stuff that we found while looking at these different size decks. And this is just a quick example to show you how the cards look in different size decks. So in the 36 card deck, we have all the possible blue, yellow cards. So these are all our unique cards, no duplicates. However, in that 60 card deck, half of them are duplicated. So now we have 12 blue, yellow cards. And in the 72 card deck, all the cards are duplicated. So we have 16 blue, yellow cards.
So our next step after we counted all the cards was counting two card swishes. So first we did that with the standard 60 card deck, and when we found that there are 46 total two card swishes in your standard 60 card deck. Next we went to the 36 card deck with one of every card, no duplicates, and we found that there are no one color two card swishes and 14 two color two card swishes. And I'll show you in just a second why there are no one color two card swishes in this deck. And then on the 72 card deck, we found that there are 8 one color two card swishes and 56 two color two card swishes. And the way that we found all of these numbers is just by manually sorting out and finding all of the individual swishes. So if we look at the blue cards, we can see that these cards are actually self-swishing. So we have three unique blue cards in your swish deck. And if you you can stack these blue cards on top of each other to create a self-swishing swish. Um, so this explains why there are no um, explains why there are no one color two card swishes in your 36 unique card deck. Um, because in order to have a two card swish with just one color, you need two copies of each individual card.
So you've heard the word unique come up a lot. So what is a unique swish? So if we look at the image on the left, we have four different cards where the top half is the same type of card, same as the bottom half. However, we could make four different swishes with these cards. But since they look the same from the deck view, we count that as one unique swish. So it doesn't matter how many duplicates of those cards you have, as long as it looks the same from the deck view, then that counts as one unique swish. And we also counted the unique two card swishes and found out that there are 22 of them.
So after we did two card swishes, we moved on to three card swishes. And obviously this was more challenging because there's a lot more cases. We actually found seven different cases when we were doing this. For the one color swishes, the all blue and all yellow each had one, and the all red and all green had none. For the two color swishes, two color three card swishes, half of them had two, and then those with double blue or double yellow had six, but those with double blue, double and a yellow or double yellow and a blue had 12. And this is just because of the nature of those specific positions, because the blue and yellow have twice as many different possibilities for a symbol as the red and green do. The three color three card swishes were the most challenging for sure. It took us a while to wrap our heads around them, but we did get there eventually. The blue, red, green and the yellow, red, green both had 8 unique three card swishes, and the blue, yellow, red and blue, yellow, green had 16 each. Here we have an example of a three color three card swish. This is a red, yellow, green. Um, and I'll walk you through this to show you how we actually got to that number of 8. So first we started with a yellow red card. So either a red ball and a yellow hoop or a red hoop and a yellow ball. Once we had our starting card, we found the 2 cards that would match with that red symbol. So for example, on this first one on the left, we have a red ball. So we needed to find the 2 cards that had a red hoop and a green ball. That way we could find our third card to complete the swishes. So we ended up with 8 because these two are the same, and 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 these two are the same. So we ended up with 8 three color three card swishes using this tactic.
So just some of our future work and goals, if we do decide to continue working on this project, we want to count every unique switch in a full 60 card deck. And because that can be very challenging doing it all by hand, we want to figure out if there's a systematic counting method that exists or even derive a general formula for counting these switches. And we also want to test how these results scale with the different size decks that we showed you all before. These are our references, and thank you for listening to our presentation. Do you have any questions?